Hi everyone, this is the first of the videos that we're going to use in this course as part of the guided notes. So the first thing we're going to talk about is the graphing calculators. I am not assuming you know anything about these calculators, so we're going to go step by step through all this. If you know how to use these calculators pretty well, you could probably safely skip these videos in section 1. But for you who don't know any of the calculators or just don't like technology, this is for you. So the first one we're going to do is this function right here. And in order to put in our calculators, notice, so let me go over to the emulator, that first of all, to enter stuff in for graphing, you have to hit this little Y button, which is the far upper left-hand corner. Notice that everything is Y equals. So to put in anything for equation, we have to solve for y. So let's go back to this equation and notice it's not solved for y. So let's solve for y. So x squared minus y equals 3. So I am going to move the x squared to the other side to get minus y equals 3 minus x squared. And multiplying both sides by -1, I get y equals x squared minus 3. So notice that this is going to be my y1 in the calculator, and this is what I need to input. So let's flip back to the emulator, and let's punch that in. So next to this green key labeled alpha is this key that has an x, a t, a theta, and an n, which I just highlighted in red. That is your variable key. Whenever you need to enter a variable, no matter what mode you're in, that is the key you hit. Now over here to the up left of the 7 is the square key. Now the quadratic functions and the squaring is such a common thing that it gets its own button. I'll show you in a minute how to do other powers. And then we're just going to do a -3 and we hit the enter key. Notice anything I hit on the left hand side it gets highlighted in red. And so now we want to graph this. So in the upper right hand corner here, we'll hit the graph button, and notice it changes screens, and there we go, there's our parabola. And we know from college algebra that this is the correct parabola because this is the function x squared shifted down 3. So let's see the other way to enter the exponent. So let's go back to our y equals and hit the clear button to get rid of everything that we have there. So now I'm going to hit the x again. And now above the division symbol, we're going to have this little caret symbol. And notice that it put an exponent in. And we're going to hit 2. Now unlike the square button, it didn't automatically go back down because we can, in theory, have additional values. We could have x to the 25th power or x to the 2 minus y, for example. So notice that if you look over here in the big window, I'm going to use my cursor to kind of show you that there's a blinking arrow right there, oops, which is now being hid by the tools tip, but I moved it out of the way, and notice there's a blinking arrow, and that means that to go back out of the exponent you have to hit the right key. And notice that the cursor now looks normal. Then we just put -3 in like we did before, hit enter, hit graph, and again we get the same function. So all nice, works either way. So let's go back to our problem. So we did our first one. So now let's look at our second problem here. So notice now that I don't have a function anymore, I have a relation. And we could still graph relations in RTIs or other types of calculators, but we have to be able to solve for y. So if you cannot solve your equation for y, you cannot graph these with these types of calculators. You'll have to use some other technology like Wolfram Alpha, for example. But this one is solvable for y, so let's do it. So we're going to have x squared plus y squared equals 4. And then remember that this is a circle of radius 2 centered at the origin. Solving for y, we'll move the x squared to the other side. I'll write that a little more neatly. Taking the square root of both sides, remember that this gets a plus or minus, and we get the square root of 4 minus x squared. And so we're going to have two functions, one for the positive root and one for the negative root. And once we put both of those functions in, that will draw us the entire graph. So going over to the calculator, we'll go to y1, clear that. And so I'm going to enter, so I'm going to use the second key here. And above the square root, or the square button, is a little in blue, the square root. So if I hit the x squared key, I will put in a square root. And then I'm going to put in 4 minus x squared. And this will give me the upper half of the circle. So let's just graph it right now to confirm that. And there's the upper half of a circle of radius 2. Going back to the equation now, if I hit down, I can go to the next problem, and I'm going to use, now, be careful. You want to use this button right down here below the 3 for a negative sign. You do not want to use this button to the right of 6, that is subtraction. And if I use subtraction, you'll get an error. So make sure when you're using negative signs, use the negative button way down here below the number 3 key. But everything else remains the same. Square root of 4 minus x squared. Enter. And now if we graph, the red part fills in. And now we have something that resembles a Pokeball here, ironically. So that's our circle of radius 2. We can actually make the graphs the same color with this type of calculator. So if we go back to the equals mode, so we can go over here, and so what I did was, I had to remind myself, I just navigated with my arrow keys down to the second equation. I keep hitting left until I get the color indicator up, and I hit enter, and I can just change my color, and I'll just change it to blue. Don't worry about the line. I think that just gives you different thicknesses or different ways to graph it. Hit OK, hit enter a bunch of times to make everything okay, and now everything is just one solid blue circle. Alright, well that's everything for this video. So our next video is going to be about using the table function, which is one of the things I think the TI-83 and 84s do the best, that the Nspires don't do very well. So we'll see how that works.